Roots. Let's get a quick refresher on what square roots are and how I find square roots. Can someone tell me how I find a square root of something? Yes?
Is that like multiplied by itself?
Yes. So square root is where I'm looking for a number times itself. It's going to be that number under the radical. So if I have the square root of 16, I'm looking for a number times itself that gives me 16. What is it? 4. 4 times 4 gives me 16, correct? Everyone understands square roots?
Yes, sir.
Now, it's not written up there, but when we have a square root, we have this thing called an index. That index is understood to be a 2. Because a square root is doing the opposite of squaring a number. So it's got to have that little 2 with it. But if it's a square root, we do not usually write it. So it's understood to be there. Okay? Today we're dealing with cube roots. Any ideas on how I'm going to handle a cube root?
Times itself by 3.
Times
So
it-
like 4 by 4 by 4.
Yes. So, whenever I have a cube root of something, I'm going to look for a number times itself again to give me that number under my cube root. Does that make sense? It's a cube root. It's 3. So it's 3 times. 4 times 4 times 4. Cube root of 16 is not 4, but we'll get into that in a second. Does that make sense, though?
Yes.
A fourth root would be a number times itself times itself times itself. Fifth root, number times itself times itself times itself times itself. So on and so forth. Today we're just going to deal with cube roots, though. So that's pretty much what this is saying right here. A cube root of a number is a number that, when multiplied by itself, and then multiplied by itself again, equals the given number. Okay? A perfect cube is a number that can be written as the cube of an integer. This symbol, I'll write it a little bigger if you can't see it. It's just a radical with a 3 in the index. This symbol is used to represent a cube root. So like I said, a square root was understood to have a 2 there, correct? Cube root has a 3 there. Fourth root will have a 4. Fifth root a 5, so on and so forth. Does everyone know what a perfect square is?
No.
Can someone tell me what a perfect square is?
Divides evenly.
Not divides evenly. Yes?
Multiplies evenly.
Not quite. Good guess, though. Perfect square is a number that I can take the square root of, and it gives me a nice integer. No decimals or anything like that. So, would the number 1 be a perfect square? Can I take the square root of it and get a nice whole number out of it? What's the square root of 1?
1.
Yes, I do get a nice whole number out of it, correct? So 1 is a perfect square. What about 2?
Yes.
What's the square root of 2?
4.
Huh?
4.
Not 4. What number times itself gives you 2?
Oh, 1.
Not 1.
There isn't one?
It's a decimal. So is 2 a perfect square? It's not. I don't get a nice whole number, do I? Is 3 a perfect square? No. What about 4? 4 is a perfect square. What happens when I take the square root of 4? What do I get? 2. So the perfect squares are 1, 4, 9, 16, 25, so on and so forth. Those are my perfect squares. I can take the square root of all those and get a nice whole number. Same thing with perfect cubes. A perfect cube is a number that I can take the cube root of and get a nice whole number. Okay, so we're going to deal with those a little bit in a second. Are there any questions before we move on to some examples? You all right? Make sure you're paying attention up here. Okay. We're just going to find each of these cube roots. So letter A. I have the cube root of 8. So I'm looking for a number times itself again, that gives me 8. Can anyone tell me what it is?
3. 2.
It is 2. Very good. Because what is 2 times 2? 4. And then times 2 again?
8.
8. 4 times 2 is 8. So the cube root of 8 is 2. When I took the cube root of 8, did it give me a nice whole number? Yes, it did. So I would say 8 is a perfect cube. So everyone understand that. Bless you. 8 is a perfect cube. Okay, letter B. I've got the cube root of negative 27. So I'm asking myself, what number times itself again gives me negative 27? Someone raise your hand and give me the answer. Not 9. What's 9 times 9? 81. 81 times 9. Yes.
30?
3. What's 3 times 3? 9. What's 9 times 3? Positive 27, right? I got a negative 27. So it's not 3, but it's negative 3. Very good. Negative 3 times negative 3 gives me positive 9. Positive 9 times negative 3? Negative 27. So I know it's negative 3. So is negative 27 a perfect square or perfect cube? Yes, because I get a nice integer out of it. Nice whole integer. Okay, C and D are a little different. They're fractions. Uh-oh. You guys love fractions, don't you? Yep. Let's think about this. Let's think about how we are able to multiply fractions. How do we multiply fractions? Straight across. So multiply the numerators together, and I multiply the denominators together. Correct? So knowing that information, what I can do is I can look at the numerator by itself, take the cube root. Look at the denominator by itself, take the cube root.
Okay.
So, let's look at the numerator. What would the cube root of 1 be? 1. 1 times 1 times 1 gives me 1. What would the cube root of 64 be? 4. 4 times 4 is 16. 16 times 4, 64. So everyone see how we handled that? Because if I multiply 1/4 times 1/4 times 1/4, I'm just multiplying all the numerators and I'm multiplying all the denominators, correct? So that's why I was able to do just the numerator first, just the denominator second, put them together to make my fraction. Questions on C? Make sure we don't have any phones out. I can tell if you have your phone out, down on your lap, texting, and yeah. Questions on C? Okay, so knowing that information from C, can someone help me out on D? What's the cube root of 27 over 125?
The whole thing.
Yep,
3/5.
3/5, very good. Cube root of 27, 3. Cube root of 125, 5. Put it together. There's my fraction. Questions on D? We okay with cube root so far? Not too shabby? Good. I'm glad. Can I go ahead and move on?
Yes.
All right. So the other day, the first day we took notes, we evaluated expressions, correct? We just used our order of operations to figure out what our expression was. So we're going to incorporate that. We're going to do the same thing, but it just contains cube roots. So we're kind of mixing the two lessons. So, letter A, 2 times the cube root of negative 216 minus 3. What do you guys think I need to do first?
So what's that?
Do my cube root, right?
It's like an exponent.
Do what?
It's like a backwards exponent.
Yep, my cube root is like a backwards exponent. Very good. So, what would the cube root of negative 216 be? What number times itself gives me negative 216? Well, first off, is it going to be positive or negative? Negative. It's got that negative under there. So I have 2 times negative something Anyone typing numbers in on their calculator to try to figure it out? What's 4 times 4? 16, and then 16 times 4 would give me 64. So not quite 4. Is it going to be higher or lower than 4? It's going to be higher than 4. Yes? Negative 6, very good. Negative 6 times negative 6 times negative 6 would give me negative 216. Now this is 2 times my cube root. So whatever I get for the cube root, I have to multiply by the 2. So that 2 just comes down with it. Okay, now I've just got multiplication and subtraction. Which one comes first?
Multiplication.
Multiplication. What's 2 times negative 6?
Negative 12.
Negative 12. And lastly, negative 12 minus 3. Negative 15. Is that my final answer? Yes, it is. Questions on letter A? You're still using your order of operations. We just have the cube root incorporated in there. Yes. Yeah. Yep. Okay, letter B. Cube root of 125. Cube plus 21. So what would the cube root of 125 be? 5. Because I know 5 times 5 times 5 gives me 125. Now I have 5 cubed plus 21. What's 5 cubed? 125. Does everyone see what happened there? Someone tell me what happened. We just got the number under the cube root back, right? Did my cube root and my cubed go away? They did, right? So that's going to happen anytime you cube a cube root. The cube and the cube root are just going to cancel each other out, so I'm going to be left with that number underneath the radical. Does everyone understand that? The same thing will happen if I have something, the square root of something squared. If I have the square root of 10 squared, the square is going to cancel out the square root to where I'll just have 10. Does everyone see that? So if I have a 4th root raised to the 4th power, that's going to cancel out. 5th root raised to the 5th power, that's going to cancel out. It has to match up like that in order for it to cancel out, though. If I've got the square root cubed, it's not going to cancel out. I'm going to have to figure that one out. Okay? But square root squared, canceled out. Cube root cubed, cancels out. So I'm okay if you skip that middle step and recognize that it's just going to be 125. Okay? I'm okay with that. Any questions about that concept? Now I've got 125 plus 21, which gives me 146. Questions on B? Everyone okay? Not too bad. Can I move on?
Yes.
Okay. Evaluate each algebraic expression for the given value of the variable. So this is just like the other day also, where it gives me an expression and it gives me a value of x. The other day when we were given that, what did we do?
Plug it in.
Plug it in. Plug what in for what?
192 for x.
Plug 192 in for x. So anytime I see an x in my expression, I'm going to replace it with 192. So I have 192 over 4 plus the cube root of 192 over 3. Everyone good? Replacing a variable with the number when we're given that variable. Okay. So someone type in 192 divided by 4 for me.
64.
64.
12. 48.
48. Earlier, when we had our cube root of a fraction, we did the numerator first, cube root of it, and then the cube root of the denominator, correct? Is 192 a perfect cube, though? Can I take the cube root of 192 and get a nice whole number? I can't. Can I take the cube root of 3 and get a nice whole number? No, I cannot. Any ideas on what I could do before I take the cube root, though? Divide. What's 192 divided by 3?
64.
64. You are able to divide before you take the cube root, if you're able to. So what would the cube root of 64 give me? 4. And 48 plus 4? 52. Questions on letter A? Good. Letter B. Can I erase letter A?
Yeah.
Letter B. 9x plus the cube root of x, and x equals 1 over 27. What am I doing? Plug 1/27 in for x. So 9 times 1/27 plus cube root of 1 over 27. What is 9 times 1 over 27? What? 1/3. Very good. Good old fraction. Am I able to divide 1 over 27 before I take the cube root? Am I going to get a nice whole number out of that? No. Can I take the cube root of 1 and can I take the cube root of 27?
Yeah.
What do I get? Not 1/9.
1/3.
There we go, 1/3. Very good. Everyone see that? Any questions on that? How did I get what? The second one? So we're taking the cube root of 1 over 27. So like on our third slide, when we had a fraction, we took the cube root of the numerator. So what's the cube root of 1?
3.
Cube root of 1. It's 1. Because 1 times 1 times 1 gives me 1, right? That's my numerator. Cube root of 27? 3, so that's my denominator. Okay? Yep. How do I add and subtract fractions? What do I need? Common denominator. Do I have that in this case? Yes, I do. They have the same denominator. So what do I do now? Okay, so what's 1 plus 1? 2. What's 3 plus 3? 6. Is that my answer? Or did I do something wrong? Did I do something wrong?
Oh, yeah, you're supposed to add the bottom.
We're not supposed to add the bottom, are we? Do not add the bottom. Keeping y'all on your toes. What do I do with my? How do I get my denominator?
Multiply.
I multiply. Keep it the same. I just keep it the same. So I get 2/3. Any questions there? That is my final answer for B. Any questions? Can I move on? Last example. Evaluate 5 times the cube root of 3x minus 9 minus 7x when x equals negative 6. Same concept. What am I doing? What? What am I doing? Plugging what in where? Negative 6 for x. Very good. Got to follow our order of operations. So what am I going to do first if we're doing order of operations?
Multiply.
Multiply where?
Under the square root,
Under the cube root.
cube root.
Cube root. Very good. I'm going to do everything in my cube root first. So what is 3 times negative 6? Negative 18. And negative 18 minus 9?
Negative 27.
Negative 27. And finally, the cube root of negative 27?
Negative.
Negative 3. So I've done everything under my cube root, and I've taken my cube root. So now I can move outside of that cube root. What do I do next?
The rest of the problem.
Do what?
The rest of the problem.
Rest of the problem. What's 5 times negative 3? Negative 15. Negative 7 times negative 6. Positive 42. And negative 15 plus 42?
87.
Not 87.
I mean, 15.
Not 57.
27.
27.
How? Yeah, how?
Okay, so they have opposite signs, correct?
Yeah, oh,
So we subtract them.
Yeah.
So 42 minus 15,
Okay, yeah.
27. Keep the sign of the bigger number. Questions on example 4? Any questions about any of our cube root notes that we just took? Any clarifying questions about cube roots? Not too bad? Can I move on to our assignment?
Yeah.
There we go. Page 13, numbers 2 through 26, all
That many?
due Monday, 8:23 on Canvas. A lot of them are real quick. Just tell me the cube root of this number. Page 13, 2 through 26, all due Monday, 8:23 on Canvas. Any questions before I end my recording?